this video, we're going to look at the Module 2.2 notes. One of the primary goals for this course is by the time the course is finished, I'd like you to be able to analyze data sets in R. So if we think about what a data set looks like, or what data looks like, we know that some variables take numeric values, so we have quantitative data. And we saw last time in Module 2.1 how we could create vectors or objects to store numbers. What we didn't look at was how we could create objects that could store characters, or things that are categorical, for example, if we think in terms of data. So the first thing we're going to look at are what are called character strings. So any value written within a pair of single quotes or double quotes in R is treated as what we call a string. Internally, just as a note, R will store every string with double quotes even when you create them with a single quote. So let's look at a couple different strings here. We're going to look at our first one, which we call phrase 1. Actually, I'm just going to go ahead and run all three of these. So notice those are up here. Just as a note, I kind of want to pause. I didn't show you this last time, but I want you to see this. Let's say that you wanted a clean slate and you wanted to start over. Notice I've got some older stuff that I've ran in here. Let me show you how you can clean these. Now, if you clean these, you will have to start over in your code in terms of what you've ran. But notice if this little broom right here, if we click that, that'll clear everything out of my global environment. And we can also go up to File, Edit rather, and go down to Clear Console, and it will clear here, so we have fresh slate. Alright, so let's define those character strings again. So notice I've ran these, and we get these values up in our global environment. So what I've done is created three different objects. Each of them has a string of characters. So looking at the first phrase, there are three types of lies, damn lies, and statistics. Notice that this string is defined by single quotations. The second one, facts are stubborn things, but statistics are pliable. Notice that it is in double quotations. So either of these are acceptable ways to define strings. Looking at the third one, notice that this quote has something in quotations inside of it. So we got statistic is the main of all inaccurate studies. So what we would like is when we define the string, we want these quotation characters to be part of the information. So notice on the outside we have the double quotations, and then we use the single quotations on the inside. And we can see if we call all three of these, we get our three different character strings. Now one thing to notice here, let's look at the length of these. So I've got the length of phrase 1 and phrase 3. Notice the length is 1. We could do the same thing for phrase 2. So R considers this one thing, or probably this string, to be one thing that is the object. Okay, so this is a little bit different. When we looked at our dice last time, we had 8 different sides of the dice. So the length of that object would have been 8. Here, the length is just 1 because R is considering everything inside of the quotations to be one thing. Alright, we can also create empty strings. So an empty string can be created just by having nothing between the quotations, and notice there's not a space here, there's nothing in there. Or we could create an empty character. Okay. So let's look at what we call the class of each of these. Notice each of these is called a character. So we haven't talked about class yet. We're going to talk about class more next week, but there are different types of objects that you can store in R. So there's numeric, there's integers, they're what are called matrices, arrays, and also character. And so character is what we have here. And notice if we compare the length of each of these, we see that the length of the empty string is 1, but the length of the empty character is 0. The reason for this goes back to how we created these. So in the empty string, we just use the quotations. So here, R is still considering this to be an object of length 1, it just doesn't have anything in it. Whereas if we use the character function, with the argument of 0, this is actually creating something of 0 length that is empty. So just a slight difference there. We'll talk more later on as things like this become important, but this is just to kind of show you that depending on how you create something, R is going to store it slightly different. Now we can paste strings together. So I've made two strings here. The first one is first underscore name, Amanda. The second one, Ellis. And then we can use the paste function to paste those together. So notice we end up with a single string of Amanda Ellis. We could extract a substring, so we use the substring function here. So the substring function, how its arguments are going to work is we're going to feed it a string, so we have twinkle twinkle little star, and then we're going to tell it to start at character 18 and stop at 23. So let's look at where those are. So starting counting, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So let's see what's going to happen here. So we're going to start on the 18th one, the L. So notice if we run from the 18th to the 23rd character in this string, we are just going to end up with the word little. And so that pulled that out. We could also do substitution using the sub function. So everywhere that we see the word little in the string, we are going to substitute it with big and twinkle twinkle little star. And notice we end up with twinkle twinkle big star. Now don't forget, if you ever want to see what the arguments are for a function, so for example the sub function, we could always do our question mark there, make sure it doesn't auto-complete. Okay. And so notice here is our sub function. So what the arguments are saying here is the pattern that we're looking for, what we're going to replace it with, and then X is the string. And notice if we go down here, we can actually see what those arguments represent. So we've got pattern, we've got the X, and then we've got the replacement. Right? So each of these that we've looked at, these character strings have been at length 1, but just like we did with numeric, we can make these longer. So for example, I could create this character string. So we're going to let X be A, B, C. Notice these are separated by a comma, similar to when we worked with numbers. So we get A, B, and C. And then notice that the length of X, when we run this, is equal to 3. Now one thing we do want to be very careful of is by default, what will happen is if you try to make an object that has both characters and numbers in it, R will automatically change those over to characters. So let's look at this example. So here I'm creating an object Y that has A, B, and C in quotations. And then I have 1, 2, 3, and notice 1, 2, and 3 are not in quotations, so let's run this. Now if we come over here and we look at Y in our global environment, notice that 1, 2, and 3 now have quotations around them. The reason for this is when we create a vector in R, each element in that vector does have to be of the same type, so we can't mix characters and numeric. So that's something to be aware about, and we'll talk more about next week when we kind of dive into some of these different data types. Alright, next let's look at data frames. So a data frame has the following properties. Each row must have the same number of columns, and each column can be a different data type, via numerical, categorical, factor, etc. And we'll talk more about factors later. You can think of a data frame as being a data set. So typically when we see data sets, they are easily transferred over to data frames. And if you're working with data in R, data frames are going to be what you work with the most. So let's look at how we could build a data frame. So first, notice here, I'm going to create a vector called name that has 3 different character strings in it, Susie, Bart, and Hope. So we can see name. If we come over here, we've got Susie, Bart, and Hope. I'm next going to create a vector called age. Now here I've defined the ages to be in terms of characters, but we could just as easily change that over to being numeric. How you store that is going to depend on what you want to do with the data, and we could always change it over, and I'll show you how to do that. So notice we've got age here is equal to, and then again we've got 3, 2, and 6. Here we're going to create what is called a logical vector. So these are trues and falses. So here we've got an object called allergies, and notice it's going to be equal to true, false, and true. So this tells me that Susie has allergies, Bart does not, and Hope does. And then we can combine all three of these pieces of information into a data frame. So I'm going to call my data set children. I'm going to set it equal to, and then I'm going to use what is called the data.frame function. This data.frame function, what it's going to do is it's going to combine those three different vectors that I just created and put them into a data frame. Alright, so notice now under data, so this is not under values, it's under data, we now have a data set. It contains three different variables, name, age, and allergies. And we can click here. And notice here we have a data set. So data frames, you can think of those as data sets. All right. So coming back here. Now maybe instead of having age be 3, 2, and 6, perhaps we really want that to be the numeric form, not the character form. So let's see how we could change that. So first, what I'm going to do is I'm going to call that piece of the data frame. So the name of the data frame is children. Notice R will auto-complete this for me. And I'd like to be able to call some of those different variables. So for example, we have $sign. So if we put the $sign after the name of a data frame, R will tell us what the different variables in that data frame are. So the one I'm interested in changing is the age. And so let's call this. All right, so we've got children age down here. So we can see that is my age in terms of characters. So let's see if we can define a new variable. So I'm gonna, on the left-hand side, do children age numeric. So what this is going to do is it's going to create a new variable called age numeric and add it to the children data frame. And I'm going to set this equal to the children's age, but I'm going to use a new function. I'm going to use what's called the as.numeric. And so what it's going to do is it's going to change those characters over to numbers. So let's run this. All right. So now if we come over to my data set, notice that I have age numeric 3, 2, and 6. So I've changed that age over to a numeric value. Now there are lots of data frames that are pre-built into R. I'm going to have you look at some of them in some of the exercises or lab this week. So the first thing we're going to run here is a new function. It's called library help equals datasets. So if we run this function, notice what we get here is information on the package datasets, and we'll talk more about packages later on. But if we scroll down here, notice there are lots and lots of different data sets. These are all data sets that are pre-built in R. So we're going to look at the state.x77 data set. So here's what this data set looks like. So you can see we have each of the different states: population, income, illiteracy, life expectancy, murder rate, high school graduate, frost, and area. So if we want to know more about this data set, what these different variables are, we can do question mark, just like we would learn about a function, state.x77. So let's run this. And notice here we get information about this data set: US, state, facts, and figures. So scrolling down here, we see the state.x77, and we get a little bit more information about this and what each of these variables are. Now notice if we look here, we see that this is stored as a matrix. Well, we want to work with data frames. So similar to the as.numeric function that we used up above to change the characters to numbers, we can use the as.dataframe function to transfer, or to change a matrix into a data frame. So that's what we're going to run here. So my new data set I'm going to work with is called state.info. So let's explore this data frame a little bit. First, we can use the class function to tell me what class this object is. And we can see that it is a data frame, so we did that last step correctly. If it wasn't, again, we could change it over to a data frame using the is.dataframe, but we don't need to because we already did that up above. So I'm actually going to delete that out of the script, and that'll be deleted out of yours. We could use the in row to tell us the number of data rows. We see that there's 50, and that makes sense because we know there should be 50. We could use the in column to tell us how many columns there are, and we see that there's 8, and that is what we expected based on the description. We could use the names function to tell us the names of the different variables in the data frame. We could use the head to just look at the first 6 rows of the data set, and we could use the tail function to look at the last 6 rows of the data frame. Now we might want to call different elements from the data frame. So for example, we might call state.info bracket 1, 2. So let's talk about what this is doing. The state.info, that is our data frame. We use the brackets to call individual elements of the data frame. Anything before the comma is going to correspond to the rows. Anything after the comma is going to correspond to the columns. So this is telling R, I'd like you to pull the element from the first row and the second column. So if we come over here and we look at our data set, I'm going to click on it here, open it in a new window. If I'm in the first row and second column, I would anticipate R to pull this value right here, so 3,624. Let's see if it does that. And it does. Now we could also do this by using the row and the column names. Now your data frame does have to have row and column names for this to work, but suppose that I want the income for Kentucky. Well, remember the states are given by the rows, so I have Kentucky and income. And notice I do have to have these in quotations because again, anytime you have something in quotations, R knows that that is a character. So let's run this. And we see the income for Kentucky is 3,712. If we go back to our data set, we see Kentucky income 3,712. So those do match. Now, just for illustration, I want you to see what would happen if these are not in quotations. Notice if these aren't in quotations, it's going to tell me object Kentucky not found. So if you have characters that are not inside quotations, R is going to think that that is an object and it's going to go looking for that object. But we know that that's not an object, so that's why we have that in quotations. We can also reference individual columns of our data set, and there are several different ways to do that. The first one is by using double square brackets. If we use double square brackets and we give R a number, it's going to look for that column. So we know the income column is the second column, so now if I run this, it is going to give me that income column. I could also just call it by name since the columns are named. We get the same thing. I could use the $ trick that I used earlier on. Now notice if we use the $, we don't have to use the quotations, and the reason for that is R knows when you use the $, it automatically knows you're going to be giving it the name of one of the columns, and so you don't have to include the quotations there. Or we could use our single bracket that we used up above, but we just put nothing before the parenthesis, nothing before the comma, and this is because we want all of the rows. Notice in all 4 of these we get the exact same information back. Alright, so the last thing we're going to talk about are the base functions. So there are a ton of functions available in R. The base functions, those are just the ones that are preloaded. So notice we've used a bunch of different functions in this note set and the last one. I didn't have to do anything special. All I had to do was call the name of the function and it automatically worked. That is because these are all base functions. They're included in base R when you originally downloaded and installed R on your computer. There are lots of different functions that are not available in that base installation, and those are going to be in what are called packages. So later on, we're going to talk about how to install packages and get even more functions than what are available in the base functions. But take a moment, go to this website here, and you'll see a big long list of all of the functions that are available in base R, and you'll see that there are lots and lots of them. Alright, so this is going to conclude this note set. As always, if you have any questions about what we looked at together here, please let me know, and I will see you all in lab this week.